Hello, now I am going to start chapter 6 electrostatic field and video name is introduction. So this chapter is concerned with electric charges which are at rest and electric field which does not change with time. So static electric field means it is called electrostatic and it is associated with stationary charges because the field is static, so there is no motion in charge, so no charge, point charge are in motion, they are at rest. So there are two fundamental laws governing electrostatic, and they are Coulomb's law and Gauss law. So first of all we will discuss the Coulomb's law because this is very important in solving so many problems of electrostatic, and it is based on this law we will talk about electric field intensity, electric flux density, energy and potential. So later on we will discuss Gauss law. So what is Coulomb's law? So we know that the two like charges repel each other while the two unlike charges attract each other. So it shows that the force acts between the two charges. This is also known as electric force. The electric force is attractive in case of unlike charges. So you can see here from this figure you can see that we have the unlike charges. So this is unlike charge, this is minus. So you can see here this is minus charge and this is plus charge, so they are attracting to each other. And these are the two charges, opposite charges. We have opposite charges and we have the same charge here. This is also positive charge, this is also positive charge, so they will repel each other. And these two charges are opposite, this is plus charge and this is minus charge, so they will attract each other. So this force is act between the charges, electric force in case of unlike charge while repulsive in case of like charge. So the laws for the force of attraction or repulsion between two electrically charged bodies separated from each other by a definite distance. I have mentioned here the distance between the charges denoted by R. So the laws are stated as follows. The force of attraction or repulsion between the two electric charges is, you can see here, the law of attraction is what? It is basically the force of attraction or repulsion between two electric charges directly proportional to the product of charge. So F, I am denoting here F is you can take it F1 and F2, is directly proportional to the product of these charges Q1 and Q2. The force of attraction or repulsion between two electric charges is inversely proportional to the square of the distance between them. So this is known as square law. This force is basically inversely proportional to the square of the distance between these charges, either the same charges or opposite charges. So the force between two charges always acts along a straight line joining the 2 point charges. By point charges, we mean that the size of charge is very small as compared to the distance between them. So F is what here? F is directly proportional to Q1, Q2 divided by R square. And I am just eliminating this proportionality sign by 1 over 4 pi epsilon naught and Q1 Q2 divided by R square. So you can consider this equation 1. So this is the law. The force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So what is this 4 pi epsilon naught? So epsilon naught is basically the proportionality constant. So its value depends upon the medium between the charges, because here we have this epsilon, and unit used for the charge, distance and force. So if Q1, Q2 are in coulomb, are in meters and force in Newton, then you can say that charge in coulombs and the distance in meter and force in Newton. So 1 over 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square per coulomb square. So force between 2 point charges placed in vacuum, if it is in vacuum, then this F is equal to 9 into 10 to the power 9 Q1 Q2 divided by R square. This is the case when point charge is placed in vacuum. So epsilon is called the permittivity of free space, and its value is 8.85 into 10 to the power minus 12 coulomb square per Newton meter. So since force is a vector quantity, and you can consider this equation 2. So force is a vector quantity having magnitude and directions. So equation 2 in vector form can be expressed as F is equal to 1 over 4 pi epsilon Q1 Q2 divided by R square and the unit vector AR. So you can easily visualize through this figure. This is the charge Q1, this is charge 1, and this is charge 2, this is R12, and I am taking here origin. So from origin this is R1 and this is R2, and this is the force here on these charges, between the charges. So you can write the unit vector AR is equal to R12 modulus of R12. It's a unit vector from Q1 to Q2. So you can write this R12 like R2 minus R1 modulus of R2 minus R1. So equation 3 you can write it as this force. You can see here, this is equation 3 where we have write this force in a vector form. So the equation 3 can also be write as, because we have this expression of unit vector, so F is equal to 1 over 4 pi epsilon and Q1 Q2 divided by modulus of R2 minus R1 cube into R2 minus R1. This is equation 4. So this is the expression of the force in vector form. I will continue this talk on next video. So thank you.